Given a function f which is continuous on some interval ab, the area, A, of the surface of revolution generated by f is 2 pi times the integral from a to b of the modulus of f of x multiplied by the square root of 1 plus f prime x squared. Where this formula comes from is quite complicated, so it's best to just try to remember it, but let's have a look at a picture of what we're trying to achieve. We are trying to compute the area of the following surface. If this is the curve f, we rotate it around the x-axis, so we generate a three-dimensional shape. The formula calculates the surface area of this shape, excluding the ends. This formula looks quite complicated, but in practice, the functions we plug into it often simplify down to give us something we can integrate. Let's look at an example. We're asked to find the area of the surface generated by rotating f of x around the x-axis between x equals 0 and x equals 3, where f is equal to the square root of 2x plus 1. So, let's first rewrite f of x as 2x plus 1 to the power a half. That then allows us to calculate f prime of x, which is equal to 1/2 times 2x plus 1 to the minus a half times 2, which is 1 over the square root of 2x plus 1. So f prime of x squared is 1 over 2x plus 1. Now, 1 plus f prime of x squared is equal to 1 plus 1 over 2x plus 1. If we write 1 as 2x plus 1 over 2x plus 1, we can then combine the two fractions to obtain 2x plus 2 all over 2x plus 1. Now, the area A we are looking for is equal to 2 pi times the integral from 0 to 3 of the absolute value of the square root of 2x plus 1 times the square root of 2x plus 2 over 2x plus 1. But the absolute value of the square root of 2x plus 1 is just 2x plus 1, since by convention we always take the positive square root. So we have 2 pi times the integral from 0 to 3 of the square root of 2x plus 1 times the square root of 2x plus 2 all over 2x plus 1. We have some cancellation here, which we can see if we rewrite the integral as root 2x plus 1 times root 2x plus 2 over root 2x plus 1. Then these two root 2x plus 1 terms cancel. And so we're left with a equals 2 pi times the integral from 0 to 3 of the square root of 2 times x plus 1, which can be written as 2 root 2 pi times the integral from 0 to 3 of x plus 1 to the power of a half. What we've done from this line to this line is take the constant factor, the square root of 2, outside the integral. We can now compute the integral. If you're unsure how to do this, you should watch the earlier video in this series on integration by substitution. After integrating, we obtain 2 root 2 pi times 2/3 x plus 1 to the power 3 halves, evaluated between 0 and 3. And that's equal to 2 root 2 pi times 2/3 times the square root of 4 cubed minus 2/3 times 1, which is equal to 2 root 2 pi times 16 over 3 minus 2 over 3, which is 28 times root 2 times pi all over 3. We did quite a lot of cancelling in these last few steps. This is something you should be comfortable with by now, but make sure you look closely at these last few steps to fully understand what we did.